Hello friends, welcome to our channel. Let's have a look at problem 2349. Design a number container system. In this video, we're going to explain the use of two dictionaries to solve this problem. So here, let me write the trick or the technique, two dictionaries. So you can also look at the video for problem 3160, that is yesterday's daily challenge problem, in which we also used two dictionaries to address that problem. So here we want to design a number container system that do the following things. One is insert or replace, or one is return. So in other words, we implement two methods. So one is change, right? The other is find. So the change, basically, the input will be an index and a number. So fill the container at that index with a number. If there is already a number at that index, basically we need to replace it. So you can think of this like a dictionary, right? If you have a key, if you interpret this index as a key, so then you reset the number at that index. So that's the one thing we want to comment. The second one is find. So we want to return the smallest index for which for the given number, or -1 if there's no index that is filled by the number in the system. So here the difference thing is that it might be different indices with the same number, and we want to find the smallest index. So in other words, there is some order relation, right? If you notice this order relation, some sorting is involved, or you can think of a heap data structure. In other words, so I'm going to use two dictionaries, and in one dictionary, I'm going to also to use the heap, specifically a min heap, right? So this idea is very natural, or this data structure choice is very natural, because we need to design the thing according to the requirement. So now let me make one comment on the containers, right? So the index can be this large, and at most 10 to the power 5 calls will be made in total and to change and find. With that said, let's look at the coding. In between, I'm going to explain the logic. So first, I'm going to initialize, add some fields. So one is ID to number. So basically, I want to record the ID as a number. So collections default dict. So I'm going to map everything to be say -1, or it means none, right? Another thing is that so here, another piece of information we need to store is number at indices, right? So means basically given each number, we want to also record its at which indices their value as a corresponding number. So we're going to have collections default dict. Then I'm going to initialize as an empty list. So basically this list, so here I'm going to use this list, use the list of indices actually as heap. So this way I can easily get smallest index if I want, right? So that's the initializer, or the data fields we want to store. So now let's look at the change, right? So first I want to change self idx to number. So I want to set this index to be the current number, and then I want to add this piece of information to the corresponding heap in the number at indices field. So what we want to do is, let me first write down. So I want to add self number at indices, right? Notice that this is a list, so I want to use it as a heap. I want to push this index into the corresponding heap. So what I'm going to do is heap q, heap push into this this heap at the current number, right? Notice that each number corresponding to a heap of indices. At those indices, the number, the value is the given number, right? So then what we want to do is index. So I'm going to implement the change like this. People might worry, because you have changed the number at the current index, then the original number at the index, you should also adjust the corresponding field at this one. So for example, assume you have original number at this self idx to number at this index, right? So then the corresponding self number at indices original number. So basically you want to do remove, right? You need to remove the corresponding index at the original heap, right? But I think this is a costly operation. So I'm going to do this, but I will do some work when I do find, right? Therefore, I do not modify this list or this heap. So now let's look at the find method. So in order to do this, notice that because I didn't do this, not all the indices at the here. So the object we want to consider is this, is self number at indices, right? So our hope is to find, this guy. So this is what we want to consider. So we hope that at here, the zeroth element or the root at the heap is what we want to return. Our hope is to return this, but it's not always the case due to the change operation. So now let's look at what we do. So first, if not self number at indices number. In other words, so this there's no index corresponding to this number. So we're going to return -1. In the else, if this does not return, it means that there must be a number or index corresponding to this number. Then we need to find that. So basically, it's a while block. So while this one, this is not empty. As long as it's empty, so there must be at least one indices corresponding to the number. However, it might be not all the indices corresponding to this number because of our treatment for the change, because I didn't modify this, right? So what we do is right? So then we first get the idx nums at indices at this number 0. This is legitimate. The reason is that this is not empty, right? So then we need to check if at the current index the number is the 1 given in this argument, right? So then basically we want to check if self idx to number. So at this idx, if it were the number in the function signature, we just need to return the idx, then we're done, right? So otherwise we need to do pop operation, heap q, heap pop from this one, and then yeah, just it. So notice that here we check this one, we get this ID, we just call the root, right? Because min heap at index 0 is the smallest number or smallest index here. Then if we check the number, if this one equals number, then we are going to do return idx. But we didn't pop, right? Because currently at the index 0, it will correspond to the smallest index, which corresponding to the number given in the argument. Otherwise, we do pop operation, right? Because this index may not correspond to the number in the arguments, right? So that's it. Otherwise, if just for safety, you can return -1. Yeah, that's the case. So this is basically the full code for this problem. So now let me first do a run. Yeah, it passes the example. Now let's look at this generic case. Yeah, it passes all the cases in a fast fashion. So here, let me make some comments. First, yeah, when you design the solution or the container, it's very important to choose the correct data structures. That's one thing. And actually, if you see here, we are using two dictionaries. Using two dictionaries actually is very luxury. So you can actually address quite a large number of problems. So notice here in the problem description, so you want to return smallest index. Then here, the heap naturally comes into play. That's why we also use the heap, especially in the second number at indices field, right? So in our value actually is a heap, or you can see it's a list, but we use it as a heap. So that's basically the second comment. So with that said, I guess that's it for the current video. You are welcome to digest and look at other videos in our channel. If you have questions or comments, yeah, just let me know. Yeah, thank you for watching.